So hey Miss Multazi, today me, Devansh, Prab and Angud will be showing you the different types of intersection of three planes in 3D space. So we were given the task to find the equation of three planes first. For the first plane, we were given 2 points, point A and point B, and we were supposed to find the line between those 2 points, and we had a line parallel to that line as well. Using the two lines, we constructed the equation for the first plane.
Now that we have the plane, now we can graph it onto the 3D graph that we made.
For the second plane, we were given an equation of a line and a random point. Using the point in the equation and the random point, we found another direction vector. So using those direction vectors, we were again able to create the equation of a plane.
Now that we have the plane, now we can graph it onto the 3D graph that we made.
And thirdly, we were given two parallel lines. Using 2 points on each of those lines, we found the third direction vector. And using that direction vector, we created a plane.
Now that we have the plane, now we can graph it onto the 3D graph that we made.
The next step was to analyze whether any of the planes were parallel with each other. We checked this by checking whether each of the planes' normals were scalar multiples. They were not. So the next step was to check whether each of the normals were coplanar with each other. So we use this by utilizing the formula of n1 cross n2, and the result of that with the dot product of n3. However, if this result was not zero, and therefore it implies that they intersect at one point only.
So after we had the three Cartesian equations of the plane, we decided to find the common point where all the three planes intersect. So for this, we used elimination for the three equations. Since we were solving for three unknowns and we were given three equations, this was doable. And after doing elimination, we found that the three planes intersect at a point which had an x value of 32.8, a y value of negative 18.3, and a z value of negative 16.6. So we used a random point which was 100, negative 20, and 30. And we decided to find the distance of that point from the three different planes. Using the equation learned from 9.6, we found out that the distance of the point from three different planes varied. From plane 1, the distance was 263 root 21 over 21 units. From plane 2, the distance was 99 root 29 over 29 units. And from the third plane, the distance was 152 root 29 over 29 units. Based on our calculations, we found out that the point was closest to the plane 2, and it was a distance of 99 root 29 over 29 units far away.
Thank you for your time. We have determined the Cartesian equation of the plane, interpreted the intersections of three planes in R3, and also found the distance from a point to all planes in R3.